Welcome to the Explainer. Okay, let's just dive right into this. Today, we're revisiting the absolute fundamental building blocks of Python, variables. Even if you've been coding for a while, refining your understanding of a variable's complete lifecycle, from implicit creation to architectural scope and right through to PEP 8 styling, is going to give your code a truly professional polish. Let's get started.
Here's our blueprint for today's explainer. 1. The basics of Python variables. 2. Essential data types. 3. Variable scope and lifetime. And 4. Naming rules and conventions.
Section 1. Basics of Python variables. Let's look at how data is actually stored. So you already know what a variable is, right? It's basically a symbolic name, kind of like a labeled box, referencing a value in memory. But unlike those statically typed languages where you have to formally declare everything up front, Python is, well, it's exceptionally straightforward. Variables are implicitly declared the exact second you assign a value to them using the assignment operator. You literally just provide the name, the equal sign, and the value, and boom, Python handles all the memory allocation for you right then and there.
Section 2. Essential data types.
Python seamlessly handles strings, integers, floats, and booleans. But what makes it a real game changer is dynamic typing. You don't have to explicitly tell Python that pizza is a string or that 25 is an integer. The interpreter just figures it out automatically when you assign it. Because of this, a variable can completely change its type dynamically, right on the fly. And hey, if you ever need to peek under the hood and see what's going on, the built-in type function reveals exactly what class your variable currently holds at that moment. Okay, so we know how to create them, but where exactly do these variables live? This brings us to a really interesting question. Can a variable be both local and global at the exact same time?
The short answer is absolutely not. Section 3. Variable scope and lifetime.
Let's explore these environmental boundaries. Variable scope basically refers to the region of your code where a specific variable is visible and accessible. Python strictly follows what's known as the LEGB rule to resolve variable names. First up is local. These are variables defined within a specific function. If Python doesn't find the variable there, it moves out a layer to enclosing, meaning variables in the local scope of any nested enclosing functions. Still not there? It checks the global scope, which are variables defined right at the top level of your script or module. And finally, if all else fails, it checks built-in, which are the pre-assigned names built right into Python itself. This strict hierarchy makes absolutely sure Python always knows exactly which variable you're talking about.
Now, scope dictates visibility, sure, but lifetime dictates existence. And there's a stark contrast here. A local variable, its lifetime is completely fleeting. It literally exists only within the function where it's defined. The very second that function finishes running and returns, poof, that local variable is destroyed and its memory is automatically reclaimed by Python's garbage collector. A global variable, on the other hand, has serious persistence. It exists from the exact moment it's declared, right until the entire program actually terminates.
Because of these strict boundaries, Python actually takes a bit of a maverick approach compared to other languages. By default, any variable you assign a value to inside a function is automatically treated as a local variable. And honestly, this causes a super common trap. Imagine you've got a global variable, and inside a function you try to print it. But then, on the very next line, you assign a new value to that exact same variable name. You'd probably think it'll print the global value and then update it, right? Nope. Python sees that assignment inside the function and decides, this variable is entirely local for this whole block. Because you tried to print it before the local assignment actually happened, Python throws an unbound local error. It's so frustrating. If you actually want to modify a global variable inside a function, you have to explicitly declare it using the global keyword first.
Section 4. Naming rules and conventions.
Okay, we know how variables work beneath the surface. Now let's look at how they should actually look in your scripts. The Python community is huge and highly collaborative. Over time, we've established strict standards to keep code clean and readable. The most notable one? PEP 8. It is the absolute ultimate style guide for writing truly Pythonic code.
The crucial point here is summed up perfectly by the creator of Python himself, Guido van Rossum. He said, "Code is read much more often than it is written." So naming conventions aren't just arbitrary rules meant to make your life difficult, they are absolutely essential communication tools. Sticking to these rules ensures that your future teammates, and let's be real, your future self, can understand exactly what your code is doing 6 months from now.
Before we even get to styling, you've got to stick to the strict syntax rules, or Python will literally just refuse to run.
Names have to be one word, containing only letters, digits, and underscores. No hyphens, no special symbols. And most importantly, a variable can never start with a digit. So my_int works perfectly, but forInt will trigger an immediate syntax error. Oh, and don't forget, Python is super case sensitive. A variable named with a lowercase s is a completely different variable than one with an uppercase s.
Once you're past the syntax rules, welcome to the realm of PEP 8 conventions. For regular variables, the standard Pythonic practice is to use snake_case. That just means all lowercase letters with words separated by underscores, like first name. But what if you have a value that should absolutely never change during the program, like, say, a maximum retry limit? Python doesn't actually strictly enforce immutability for variables, but by convention, we write these constants in what is delightfully called screaming_snake_case. Yes, all capital letters. It basically acts as a loud visual warning to other developers saying, hey, this is a constant, please do not reassign this. Now, here is a very specific and honestly somewhat surprising rule straight from PEP 8. Never ever use the lowercase letter L, the uppercase letter O, or the uppercase letter I as single-character variable names. Why? Well, depending on the font your code editor uses, these characters are virtually indistinguishable from the numerals 1 and 0. It seems like a tiny detail, but trust me, it saves massive debugging headaches down the road.
Speaking of massive headaches, you definitely want to avoid shadowing built-in names. Python has all these built-in functions and types, things like list, string, dict, and ID. Because Python won't actively stop you, you could theoretically just name your own variable list. But if you do that, you completely hide the actual built-in list tool from the rest of your program, and that causes incredibly subtle bugs that are just a total nightmare to track down. Always use descriptive names like my_list or items instead.
So let's pull this all together. All of these concepts basically converge into 3 golden rules for handling Python variables like an absolute pro. Number 1. Embrace dynamic typing, but use descriptive names so the inferred type is super obvious. Number 2. Keep your scope as local as possible to avoid messy global states. Pass data in and out of functions using parameters and return values instead. And number 3. Stick to snake_case. Avoid those single-letter mysteries so your code basically documents itself.
And there you have it. We've covered the complete life cycle, from implicit declarations and dynamic typing, right through navigating the strict LEGB boundaries of scope, and finally mastering the clean aesthetics of PEP 8. So I want to leave you with a bit of a challenge today. Open up one of your current Python scripts, take a hard look at your variables. Are they descriptive? Are you relying maybe a little too heavily on the global scope? Are you shadowing any built-ins by accident? Take just 10 minutes to refactor your code applying these structural and styling principles. I guarantee you'll be amazed at how much more readable your code becomes. Keep coding, keep refining, and I'll catch you in the next explainer.